where to start, and I'll mute myself.
Okay. Thank you very much for introduction, Assam. I will just introduce a little bit myself. We started with the company 22 years ago. Since about 10 years we are concentrating on linear scheduling, and we have now the 8th generation of TILOS 8 that is coming out soon. We are experts for linear scheduling, and I want to give you first a short overview what we are going to do. In the first step I want to show how TILOS basically is working. Then I want to show a case where we import data from TILOS that was used as a planning system into P6 using exchange of resources, WBS, and also a progress case. Later, as we are talking about Metro, I will show a case how to create a combination of piles and decks in a very quick way using the repetitive work planning inside TILOS. TILOS is a system that is combining the geometry with the schedule. And so we bring in a lot of technical information into the schedule, and that's why the engineers that are normally not very much like scheduling, they like the way how TILOS expressing the schedule, because there is a lot of technical information to analyze if the schedule is working or not. Usually in the US they produce 40-page or more long schedules that are printed on subsequent pages, and they can easily be converted mostly in a one-page size of the print that is giving the main idea how the project should work. For example, on top there is a little map which is showing the properties. Those which are acquired are in green, the others in red, and we have then activities, those rectangles, to see which areas are blocked for work because there is no permission to go on this ground. For this we use activities that are shown as rectangles. In the other case we are using linear tasks that show the movements of the crews. What is specific for linear projects? The most important is that we have an axis which has a measurement system in kp or in miles, and based on this measurement systems we show positions in the project and quantities. And then we plan the repetitive work along this axis. We have a fixed production sequence in which we have to execute the project, and we have restrictions like daylight, frozen zones, or heat, where we cannot work in certain areas. And the goal is to minimize the total time of the crews to avoid crashes and reduce by this the project duration, meaning we can also reduce the cost. For example, in this is a typical small sample of a linear project. You see the distance axis horizontal, the time axis vertical. Below there are ribbons showing in which section I am, in which territory, or if there are crossings, river crossings in blue or railway crossings in black. And then we got here a little rectangle. These are environmental areas where work cannot be executed. If we plan now activities crossing these areas, then there is a clash happening, and we have to move these activities down that they don't match these rectangles. TILOS cannot express only activities as a line. It can also be curved if we compile the data from profiles into the activity. If you look at the bar chart beside, we have two activities. One is following the other, but we don't know what is happening inside, and this is expressed here with the red line. So we have two clashes where the red line closes the other, and we have to move the rate down. For this case, we use so-called distance links, which keep the activities in a certain distance to each other and is maintaining this over the whole length of the task. Another strength is that we use side data in forms of profiles, elevation profiles, quantity profiles, and so on. And we can compile this into the schedule without using complex 3D CAD models like it is used in BIM. Here is the road project that has the elevation profile. It shows the quantities. It shows the layout of the map on top. And the green activities, these are the cut, and the red one. The green are the fill, and the red ones are the cut. The planner does not need to calculate the quantity in each section. TILOS calculates that automatically and sets the duration of the activity. So the first work, setting up a project, is usually getting all this geo information into the schedule, into the plan or into TILOS before creating activities, because then we can make use of all these quantities. A very good overview is giving the so-called distance Gantt chart that you see here below. The distance Gantt chart is showing, first of all, in which area work should be executed. For example, here these green ones, these are the cut ones, and the red ones, the fill. And then I get the location where this has to be happen. And then in the text panel, we see the total quantities, we see the actual quantities, what has been achieved, and the remaining, and also the progress percentage completed. Of course, TILOS can show the histograms along the time axis and the distance axis horizontal or vertically, and compile this into a real schedule. It looks then like this. This is a 45-kilometer long road project that was done in Norway, where the bidder used this in the early project stage to calculate all the need of quantities, the labor works, in order to build his estimate. A Swiss project was done for repairing a highway section under traffic, and they made 3 stages of the project because they were splitting it in 3 phases. If we zoom this a little bit in, then we see that the orange part is always the one that is not under traffic and where the repair works go. In the next stage of the project, then the traffic goes in the inner part, and the outer part is at the moment under work where the activities are planned. This client could make clear by this that with his concept there was minimum disturbance of the traffic, and by this he got the contract. This is the overview plan of the Bombela train in South Africa. This is a railway project that was executed by a French consortium, and they made at the beginning first a plan in TILOS containing about 1,200 activities, and they pushed this later to Primavera because this was a must based on the owner, and they were then making from this 1,200 activities in TILOS, they were growing this up to 30,000 containing all the contractual microtasks. The problem on this project was that it was not just something that was built new, it was partly a repair, and partly there were new sections built. The left part is done underground and the rest is overground. Along the axis, we could not just count everything from 0 to 70 because each part has their own measurement system, so there was no constant distance axis, and we solved this problem by making different columns, and each column was representing one part of the project. In the left area, you see the tunnel drilling and also this rectangle is building the stations, while in the right side, where we are overground, we have other types of activities. We got here these triangles in yellow and red, and this represent a cut and fill section. So the triangles that are standing on the top, they are cut, and the others are the fill. And then at the end, you see these big ribbons. This represent the installation of all the rail equipment and the testing phase, and then later there is the handover of the whole track. Here is another sample from a tunnel that was built in Norway. They were also using the exact quantities based on distance profiles to calculate the durations of these tunnel sections that were built in open cut. In the railway industry in Germany, we use it very intensively for repair projects. Repair projects usually start on Friday evening while the track is completely closed, and the track is reopened on Monday morning, and within a precision of 15 minutes the schedule has to be supplied. For example, this yellow area, this is a track renewal train. He is taking the old sleepers out, installing new sleepers, and at the end the front of the train is driving on old tracks, and the end of the train usually on the new tracks already. And this is followed then by the activities where the ballast is put to the rails. Then we have the tamping and another ballast section, and so this is followed until the end. The rails are again welded. We made also an animation for this that you could see the project in the Google Earth map, where each line is representing one activity here in this TILOS, and then you can see how they are moving. Finally, we can record the GPS coordinates from the main machines, for example here in the 15 minutes section, and we can convert these GPS coordinates into distance coordinates and then show the exact movement of the train in relation to the plant. And from this we can then, in an easy way, measure the progress and update the schedule in time. The tunnel builders usually work with profiles in order to get the exact speed of the tunnel drilling process. At the moment we are in Austria helping to make the early plans for one of the biggest tunnel projects in the world. It is the Brenner Tunnel, and there we take all the data from big Excel tables up to 50,000 lines and compile based on macros activities representing the drilling of the tunnel and also the finishing work. And in this project, TILOS is the only planning system that is used at the moment. There is no Primavera, no MS project. It is just done with our product, with TILOS. The challenge is to get the quantity-based cost as well as the time-based cost, because, for example, if this tunnel drilling machine, they have monthly costs of up to 500,000 euros, and if this machine is not working, this is just costing money, and we try to make the usage of this equipment as short as possible by optimizing the building of this tunnel. This is the metro of Copenhagen that was also built with TILOS. Here the usage of TILOS was mainly to optimize the usage of the tunnel drilling machines. These were planned first, and then backwards from the tunnel drilling machine, the milestones for building the stations were calculated. The stations itself, for each station, they made a plan in a traditional way, in a CPM Gantt chart-based system, but we were updating the milestones in each of these, in this case, MS project files. So we could easily get the interaction between the linear and this stationary work. One area where TILOS is also very intensively used is the pipeline building area, and we use this in combination with Google Earth in order to bring in an easy way the maps on top of the linear axis. But more important is to show the progress that we do along the right-of-way. So we can show with these thin lines where the different crews have to perform their work, and for each time frame, for example for a week, we can show where the crews are working exactly in that week. If we step 1 week forward, we see the movement of the crew in relation also to the time distance diagram. If you want to see what is finished until that date, then we can fill the whole lines, and we see that this left part is completely done and this right part has just begun. For the controlling, we can then import the sections done by each crew. We are not importing a percentage completed for a whole activity. We are importing which sections are already done and which are left for later work. This can be imported into TILOS because this is usually recorded on site using Excel tables or other database systems, but we import this, and then we can show exactly which part of the distance area is done and which is left, and we calculate the percentage completed that was planned. For example, here 40%, 34%, and 26% is the actual progress, so we are behind the schedule. And we show this also in quantities, which quantities are done and which are remaining, and we can compare the actual work rate against the planned work rate. Here the actual is 200 behind the planned. This we can then convert into S-curves showing the actual progress in percentage against the planned from the baseline. And in an overview plan, again a distance-based Gantt chart, we have the whole project on a small piece of paper. The bars are filled in that sections where the work is already done, and they are empty where the work still has to be performed. TILOS uses mainly 3 graphical interfaces. It is the activity list, it is the distance, the time distance chart with all the technical information on top, and we use a Gantt chart. Making changes in one of the 3 elements, we get an immediate update of the other views to the project as well. We can open the application multiple times and copy data by drag and drop from one project to the other by updating the data. For example, one usage is that we copy complete sub-projects from part plans into one central plan in order to see the overall situation in the project. Very strong effort has been spent on the exchange strategy of TILOS. We can exchange data with Excel using the clipboard, but we have also XML-based interfaces to take or to exchange the data with other applications, not only activities, but also calendar information, resource information, and cost information. This can now work also directly from Excel, where we can bring in multiple sheets, which I show you later. TILOS can be used in any project stage, from the pre-design to the procurement, execution, and also if special studies have to be done, we can use it also in claim analysis. The most usage we have for now in the execution phase, but more and more clients that use TILOS since a longer time start already in the pre-design and in the planning phase. For example, in England there was the HS2 Planet, and there TILOS and Primavera were used together. TILOS should present the overall schedule in a small but 2-meter long and 1-meter high plan in order to get an overview how the project is working. And who is using TILOS? Here is a section of logos from our clients. We got, for example, in Germany, we got 9 of the 10 biggest construction companies using TILOS. The one that is used is Goldbeck, but they are not doing linear projects. From the 200 largest construction company and the biggest 23, we see that there are only Japanese and Chinese companies left in our client list. This is a job we are going to do now to be also more present in Far East. In the engineering office, we are very happy that we have won Bechtel beginning of this year. They have appointed TILOS to be the product of choice for linear projects, or Dresden Sommer, which is a German company. And we got a lot of railway companies, we got railway operating companies, but also the suppliers like Alstom, Siemens, and Bombardier using this on their projects. And for the tunnel, these are the 2 biggest tunnel projects in the world. It was in Switzerland through the Alps and also in Austria. And our clients in the pipeline industry. And this is a short introduction, and I want to show you now how TILOS is working. As I said, we are combining technical information with schedule information in one simple plan. So I have also prepared now my template in a way that we got more space for the technical information than here for the schedule. The distance axis is horizontal, and in this empty area, in a simple way, we are drawing here a rectangle, and we are inserting a graphic, and this graphic we can size and move, and that it matches with the coordinates of the distance axis. There is also a function that can do this. Here the adjust position, and I draw a rectangle between 2 points from which I know their station numbers, and I type in 1200 and 2100. I click on OK, and then this gets here adjusted to these 2 points. If I change the scale horizontally, then the graphic is also adjusted in a way that the distance coordinates always match. Very helpful during planning are grid lines that show important station points, and this I can import, or I can define in TILOS, setting up a table that generates different grid lines. But to make my life a little bit easier, I go to Excel, and there I have already such a table prepared. I copy this into the clipboard. We say import. Let's delete this existing one and import. Click OK, and then I got here these grid lines in the time distance area, and as well here under the ruler with the name of these station points. We got here also a list of stations giving the height of the road and the length and the cut and fill. So we copy this to the clipboard, and there is another profile which I import now. Here we got the field mapping, which information is in which column of the spreadsheet, that I can easily paste this and show the data now in the project. This elevation profile draws me here a diagram and coloring the different sections different, like here there is cut and here is fill. We are just checking which line is over the other, and by this we decide about the coloring. We do not only generate a picture, we are also creating a diagram giving the exact quantities in this section here. So how can I use this information about quantity over the distance on creating a schedule? Planning with TILOS means we just draw activities directly on the screen. Of course, we can also add them in a table, but doing this graphically is much more convenient because we see exactly the result of our planning. So TILOS is working on the base of so-called templates which contain color settings and further data, so that I can just draw this line, and I don't need to make any further edits. I don't need to type in even the name or other information. Everything is preset from the template. Drawing is very comfortable because TILOS snaps on these grid lines, as you see, though I don't need to be very precise in drawing because the line is directly snapped. If I want to work the other direction, we got a tool that says change direction, and now we are starting the work here at the river and then working here in this direction. How does TILOS calculate the quantities? There is a special tab for calculation. We can just type in a quantity, let's say 25,000 square meters, with a work rate or productivity of 240 square meters per hour. The software calculates the duration of the activity and updates immediately the drawing. For example, if the productivity changes, then the activity is updated. The quantity, if it is constant over the distance, can also be calculated by the length of the activity. If I say we got 15 square meters of topsoil removal for each meter of the track, then TILOS calculates here 40,500 for the whole length of the activity. And if I change the length of the activity now, the quantity is updated, and by the quantity also the duration. Once I have planned one activity, then we got for one or for multiple activities, we got copy functions where I just need to enter new coordinates, and a new task with the exact calculation of the duration is created. Now I need to type in the distance coordinates, but I can also open this combo and select from this list of station points that I have imported. I can just select the points, and then the activity is automatically created in this area. You see that because the copy has a shorter distance, it has already a shorter duration calculated. This activity can now be linked with this one graphically, and with the F9 key it is rescheduled. So we see much more information than a Gantt chart. We see that they start at 2,700, work in this direction, come back and do the rest then. So there is mobilization needed inside this topsoil stripping. The next work that is coming is here the soil removal. And when I draw the soil removal, then we see that we got not a linear activity, we got a curve. The curve is corresponding with the quantity profiles here on top. So for example, if my activity ends at, or starts, is only a shorter part, let's say this 250, then I got 5,300 cubic meters, which is exactly the quantity which I have in this compartment of my histogram showing this 5,300. If I make it longer, then the quantity grows, representing always the quantity inside the start and the end. If I move the activity, then you see that with each position it is automatically recalculating, getting the quantity from the distance profiles for an automatic calculation. This means for the planner that if he has imported before the quantity profile, he can very easily calculate or estimate the duration of his activity based on these profiles. The next advantage that TILOS has against traditional planning systems is when can the work of this crew start in order to get the collision with the topsoil stripping. So usually we have then to make some side calculations, or we have to split the topsoil in two activities in order to calculate the start point for this activity. TILOS does this in a way that we can set a distance to predecessor not in time, but in the distance value. And if I press now F9, then TILOS tries to make these two processes parallel, but keeping the distance between these two activities. So this is the basic way how TILOS is working. We just draw activities in this time distance diagram, we link them and we reschedule then the activities later. Now I will load an already fully planned project that looks similar to the one I showed you. And so you see that we got here the same on top, and here the activities that are linked. We got here then this pipe laying activities. Here we got a bridge. The bridge we can also show as a Gantt chart, and once we change, for example, the activities here in the Gantt chart, then in the time distance diagram, the rectangle is automatically updated. Of course, I can also expand this summary task here in that view, and if I move now the activity, we see also the detailed tasks moving. What else is added to this activities, new in TILOS 8, is now the ability to create a hierarchy work breakdown structure and assign this to the activities. Here under the name, user can select now the work breakdown code for the activities. The activities here, this is again calculated based on a profile. They are loaded with resources. We got here 2 permanent resources, assistant and foreman working on this activity, and we have also modeled income for each quantity or for each square meter of this activity clearing. We get a certain amount of money. So for this activity, this means that we get paid based on quantity, but we have codes based on time, and the work rate is deciding if we make profit or if we lose money. Here you see that, for example, we have costs 1.80 euro per square meter, and we get only 1.16, which means that in this case we lose money on this activity. For the other activities, like here the pipe laying, we got also further resources allocated like pipes, which is material. So we got the same set of resources like we have in Primavera. We can graph them along the distance axis, so we can also calculate how much 1 kilometer of the project is costing, not only over the time. If we change the schedule and we do a recalculation, then the histograms are automatically updated. So with the comparison of cost against income that we see here, the red line is the red are the income and the green are the cost. We can then also generate a cash flow curve showing over and underspend along the project. But this project that was planned now in TILOS, I want to import this into Primavera. And we got here the project ID that is later used inside Primavera. I call this import 001. The data exchange works based on the API, and we got here 2 major functions. One is import to Primavera and the other is export to TILOS. In the first, we take a TILOS plan and push it to Primavera, and in the second, the reverse way. So I click now Import to Primavera. This integration program is communicating with TILOS and is identifying that after import.hsp is the open file. And then we select a profile. The profile contains information about which types of information should be exchanged. I will show you how a profile looks. For example, this is a profile that we are now using, and these are all the objects that are exchanged. For example, the cost centers, resources, calendars, the WBS structure, tasks, allocation. Well, you can tailor the data exchange exactly to your needs and also decide which fields in TILOS should go to which field in Primavera. For example, end distance is not known in Primavera. That's why we use a text field to code the distance, start, and end coordinates. So on behalf of my profile, we are now exchanging the data whoops. Next. Okay. I had this too long open. I need to restart this program because it got a timeout. API. So we are logging into the database now. I press OK and say import, same project. And now it says that my project import 001 does not exist. Do you want to create a new one? And I create the project with its new ID. Project is created, and now we are starting the data exchange. So it's importing the calendars, the categories, the resources, step by step, all data are expanded. The most work we have to update all the library information in order to model resources then in the next step. So the exchange is finished. I can now go to Primavera, press F5 to update the list here, and my new project, this imp01, is here. And I click on Open Project. It is getting loaded, and here is the result of this import. If I select an activity, we see that it has a WBS assigned, and the project was from my last visit already structured based on the WBS. So the multi-level WBS code is one-to-one exchanged. If we look at a resource let me I will remove this in order just to have this. So this is the schedule now as a flat list. If you select the activities like this topsoil stripping and we go to resources, then we see that we got here the resource assignments done, we got the machine, and we got the operator. We exchange the hours and the cost. And by this we cannot exchange all the different calculation models from TILOS because it is not possible in Primavera to make a quantity-based cost assignment. That's why we made here this total values only. The income that was modeled as a cost assignment, this we model as expenses. So here we got the income of 86,000 for this activity. So the result of this data exchange is that you can prepare a project completely inside TILOS, and you can merge this with all information about links, calendars, WBS structure into a Primavera project. Maybe as a whole project or as part of the project, maybe just the linear part, the track and the stations, like in this metro project in Copenhagen, can be planned then with Primavera. Now I'm coming to the next point of my presentation. I want to demonstrate how we can plan a little bridge or an elevated part of a metro using the function for planning repetitive activities inside TILOS. And the goal, what we want to achieve or what we want to make, is we want to create a little plan that looks like this here. We got here a grid representing the positions of the piles. Then for each pile we have planned 3 activities, which is the foundation, the pile itself, and the girder. And this we do for each pile we have to build. And then we make the deck installation, and here we have 1 activity for each span between 2 piles. And we see that depending on the length, for example, or on technical difficulties, we can have different durations for the activities. How to create such a repetitive schedule just with a few clicks or with a minimum effort. I start with an empty project. And I save this under another name, not to destroy my template. Though the first thing is how to get the grid in that is representing the positions of each pile. For this we got again an Excel table that contains here a list of each pile that has to be built. It has an ID, a long hexadecimal one, which is unique in the world. And then here we got the name of each pile. We got the station values of each pile. And we got, as I have been taking this from Google, we got also the longitude and the latitude coordinates for each pile. Then in following columns, we have been calculating the duration for each part job, for example, for the foundation, for the piles, for the girder, for the deck, and also the length between two piles. This is the span of this deck. So again, I take here this part into the clipboard, set Control-C, and I have in my project prepared a profile that is called piles, and into this, with the predefined setup of the columns, we are now importing the piles. And you see I got here now these grid lines. In TILOS you can import ready-made graphics, but there is also an option to use the TILOS library with graphics in order to make here little drawings. So you can now draw a picture for each pile or copy it, and then you can produce this drawing automatically. The graphic library, you see here below there is this library for the symbols, and here the different symbols can be created. For example, here pile storage, here the pipe, the symbol for cut, and so on. Each symbol has a name, and we can also import the position of the symbols using the clipboard. For example, we always use the symbol pile, giving him the name, and then have the start coordinate and the width on which layer it should be, and should it be left or right orientated. I take this data, put it to the clipboard, and there is an option that says import symbol from clipboard, and I got here the whole visualization of my project done. Usually people use different colors for cut and fill or so, or it can be, it's very flexible, everything can be imported. So now I want to plan the activities for each pile, and here we visit first our library, because we got not only task template libraries, we got also task groups. And here we can, for example, define, maybe it looks better in the Gantt chart, the sequence of activities that have to be executed for one pile. So first the foundation, and then the pile itself, and then on top the girder. Now, if I go here and click and draw this here, then I can insert these task group piles at the distance coordinates, how I was drawing it, and then I got here these three activities built, and the activities are already pre-linked. So I need to repeat this around 20 times, in longer projects even more. But of course there is a shorter way. I can draw here one rectangle, and then the insert method, not by coordinates, I say by distance profile, And now at each point of the profile, this sequence will be automatically created. So we got task at profile point, or you can also span a task between two profile points. That's why there is a second option. We can link this activity, and the task name should be the name from the template plus the name of the pile. If you want to do it only in a certain area, we can do this only between 0 and 500. So we press OK. And a sequence of all these piles here is created with the links of the activities. If I want to move this here down, or change one of them, reschedule, make all. Now we plan the deck work. Here we got two options. We can use here the template bridge work with steps. So I plan one activity, and this one activity knows each pile already. Why? Because in the calculation we have used calculate duration based on the profile piles and use the data field D. Deck. This is the duration of the deck, so we compile the quantity here and get the duration of this automatically. Here, this middle section, this takes longer. So, for example, if I go to this profile and I change duration of the deck, let's say for this pile at 112 from 10 to 30, then of course this deck here gets another duration and the rest gets automatically updated. So sometimes it is not good for synchronization to make these to make only one activity. It is better to make for each section an own. Because I need this later, let me make one thing. I select all these activities here and make a multi-edit and write here the code pile, that I know later which activities are piling works and which are deck works. So to create now for each span an activity, we got also a function which is create repetitive activities. And here we select which template we want to use, our bridge segments, and then repeat option is not by time. We can say make every day an activity, but again we use the distance profile. And we say task between profile points, and we want to link the activity. The duration or the quantity comes from the field deck. So we got all edits done. So we press OK, and we get now single activities with the pre-calculated duration from the profile. Okay. So you see, with these repetitive functions, we can very easily create a big number of activities without a lot of editing works. This is very helpful, for example, for creating the work for the masts for electrification, or for creating activities, for example, for these culverts. Wherever the profile says here is something, then a task for this is generated. Good, and now we want to visualize this project in Google a little bit. So we got a KMZ file. If I double click on that, KMZ is the file format for storing geo information that can easily be monitored in Google Earth. It's a little bit slow loading. Come on. And is zooming directly into Karlsruhe, where I've been taking a little section of 1 kilometer where I want to build this elevated bridge. In the near future, they will indeed build here a new tram system over a tunnel. So based on this route I have just been drawing before here in Google Earth and exported this as a KMZ file. But how can I link this information now with my schedule? For this we made an add-on. And into this add-on I can now load the KMZ file in order to get this path information visible here. So it's the same part of the city, but there is nothing, the file is completely empty. So the first step is to go to import and import a KMZ file, which is the same that I had right now, this Karlsruhe. And it analyzes the content of this file, so we got 4 place marks and we got 1 path which we are interested in, so we import this. We gave him a style. We want to show the path symbols, which symbol should be used, and display text we don't want to see. So I import this data. The path has been imported, and now we see this path here. Each place mark is representing one pile, and during import we have calculated here the KPs, the station of each pile in my TILOS diagram. Now the second thing we have to do is to import now the schedule, and this we do here with the import schedule. This works in the same way as with the Primavera exchange by TCP/IP in the background. We select a project and we get a profile and we click on import. So the data is imported, and now we make use of what we call a scheduled display set. And here in the scheduled display set we define which activities we want to display how in this Earth environment. So the representation is a line for the linear activities, and then we can here define different task lines. And the important thing is the filter. This is the filter is take only tasks where task template is bridge segments, and to decide how it should be represented, this is just defining the colors for the different states. So for example, for scheduled it is red, and for performed later it will be green. Okay, if I activate this and click OK, here I can check if I get activities, and I see that I have no activities. Which is not good. Bridge segments. Okay. I will do the import again. Segments. What have I? My good. In order to shorten this, now I will just load my already created sample and look for the problem later. Okay. So the filter shows me which activities are found based on that filter here. And it shows me now the planet state. And now we got here on the bottom, we got the time slider. So we make only this. And with the time slider, I can now simulate each project state. For example, on the 25th of December, the deck work is done until that point here. Or when I slip forward, then it is done up to this point here or here. So these are the linear activities. I can also show the pile works. If I activate the pile works, then I got here a filter where I have in each text one field the word pile. That's why I was adding this before inside TILOS. And then based on the anticipated progress calculation, I show then a different symbol for this pile. And these symbols can be defined free. You can use your own graphics. And you see at this point all the okay, here is on the 12th of November. We see here the situation of the progress. These 6 piles on the left, they are built, and this one has 62% progress. If I click on this, then I get the exact information about each activity that is behind that symbol. And if I click further on details, I get the task list with all the attributes for this activity. So the idea was, again, without big extra effort of making a CAD model, to get another visualization of the project in a technical way on the satellite pictures that I can maybe use this as presentation or get information from the areas around that may influence my construction process. So this is the end of my part that I was presenting. I think Mevlut is now taking over and presenting a few other aspects of already with TILOS Planet projects. Are there so far questions to my side? Okay, Michael, what is your question?
All is in mute, so they have to type the question so that you can respond to them.
Mm-hmm. Mevlut, can you take over? Because I have no access to this question list.
Okay. Thank you, Mr. Hubert. And during my presentation, we can check the questions. And can you please give me the presenter rights?
Can I do that, or will Bazam do that?
I've changed the presentation. Is now Tunas doing it.
Okay. Thank you, Mr. Bassam.
Thank you.
Okay, at my part, I will not take your much time, and you will be answering your questions as well. Here I have a few projects to share with you, and these projects are about railways and metro projects. And as you know that TILOS work in a graphical way to produce a time distance chart. And when we look at let's start with the underground project. When we look at the overall in our projects, the main idea of the TILOS having our project in time and distance chart. So when we are doing this, also we are combining our geographical data. So when we look at the overall, this is one underground project. And when we look at, we are able to see our stations, and such as station A here, switch box and emergency exits, and also we are able to put our tunnel profiles where it will start, where it will end up, and we can bring our all site information on distance access. And in addition to this, we can add our geographical situation. On the top, we are having our distance drawings. Please see that you can have your drawings in CAD file, or you can draw in TILOS as well. You can display your nonlinear works here. Please see that the site wasn't so linear, so we merged the linear parts. So you are having a linear site to display in TILOS. So there is no problem if there is curves in your project, so you can display this in TILOS, synchronizing with the time distance. TILOS is working with the Excel exchange. So here I don't have profile, but when you are planning your construction site, and this construction stage includes continuous updates of the plan during construction. So we are having our data in Excel file, and from the Excel we can bring our project data easily. If there is some change, we can easily change in Excel and bring to TILOS. at the moment I have elevation profile in TILOS. I will be bringing my elevation profile and I will display on the distance based. In Excel, I have top of rail, existing level, and where will be going to distance level we will be seeing, and just I will be copying all of them, putting into my TILOS file. Here the aim is showing how simple bringing data from Excel. I have elevation value, and when I import this data, which I have already in Excel, so at the background, please see now I will be having all profile, and all the distance I have profile. What it means that colors also indicating you meaning, and blue colors, please see that existing level which the owner of the work gives you, and here please see that this is red one, it is the top of rail, and this is the for TBM area which you are going to build your metro. So this will be underground, and you are seeing your all visibility on the site. And in addition to this, we will be having our activities, and we will synchronize activities with the distance profile. And let's focus on the activities. And on the left side, you see that this is the time based, and I don't have any information, but when I planned my project at the beginning, let's bring our information. Please see now, we had our stations, and at the bottom we have extension of the stations which will help us to plan our project. And the red ones, it indicates that here there is station, and this blue one, it indicates that there is switch box in our project. And now the most important thing, having our TBM and planning the TBM and for the station works planning. And here let's bring our TBM order. We can start with the TBM order, and these are already created. I am showing you prepared project, but how you can manage this I'm just showing. And let's look at the years as well. Okay, this is the year 2013, and when we look at how many TBMs will be in our project, and there will be 4 TBMs, so we are displaying this. When we load other activities, let's say that design works, manufacturing, and when we look at our activity, now we are seeing that when it will be completed our manufacturing works, and directly we will be able to see in our project. And based on this, when we bring our other activities like TBM transported and the TBM assembled, and later on, most important is the position of your TBMs, and looking to your milestones and defining your works and work rates. And now we can just look at that. This is the TBM. When after the assembling works, you can start with the work rate, which is your work rate, and when you start the works, first 30 days at the learning curve, you will be having 6 meters in the day. So after the learning curve, you will be seeing your productivity rates, and it will be 13 meters in a day. And looking to your milestones, you can plan your project, and here there is you see here there is a milestone, which means that you cannot enter to this station before this date, because there are multiple contractors and you are not allowed to work in this project. If you plan for your project X position, which means that your TBM is coming to your station earlier than your milestone, so you will have to wait here till the station access given to you. So in TILOS, you can see distance-based your constraints, and you can manage your works. And there are 4 TBMs, and from the left side, the TBMs are also coming. And looking to this, and just calculating your work rates. This TBM is working 14 meters in a day, and we can just look at that when the works will be completed for the tunneling. So, and when we bring the other activities, let's bring our station works as well. When we look at the overall, we can just look at the overall in our project. Please see that these are shown in pink, and they are our stations and station works. When we focus on our station works, and we will be seeing the details. And now let's see station works, and please see that TBM is working here, and in the station you have your connector which you need to move the TBM here, and you need to finish your station works till that day. So here the aim just to having the contractor's structure here, and you need to complete your excavation works, base level works, concourse level, and after that TBM will be reaching the area and there will not be delay. So here you will be able to monitor when your station works will be completed and when the TBM will reach to your station. And there are more details which you need to follow, which you can follow, such as cross passages. If you work, you can analyze that. If you work with two teams, please see that links are defining that two teams are working. When you focus more, and the two teams are working, following each other, and when you can finish your works for cross passages, and for the other side, please see that from the right side, there is only one team working, and when you complete your work and when your team can finish the work. And on the time distance, you can follow overall of your project, and at the bottom, to read your project, you can have your legend, which is helping you to read your activities on time distance area. So this is the one underground project, and you can type to your questions, and the TILOS allows you to work in the same project with multiple contractors, how it is being, and you are having sub-projects, and on the master project you are just merging the projects. So as an owner of the work or as a contractor of the work, you can collect the sub-projects, you can divide based on the sections or based on the kilometers, and you can merge the files in one project and to see the conflicts and to solution of the conflicts. Here, for example, for the contractual design, and there is needed to give access for the contractor, so at this point the other works cannot be handled in this area, which is referring that your switch box. And in addition to TBM works, also you can show your atom excavation works. Please see that these are open cut method which you are doing to your works. So when you work, also you can use atom excavation, and these activities can have work rates. So the works are harder doing cut and open. So here please see that daily 2 meters it is allowed to work. So when you look at the overall, you will see that. And after you loaded the resource and cost, also you will be having the details. And this is the overall. When you would like to get this, you can use this at the early stage of the project, at the tendering stage, just to giving offer. And also you can detail this after the project start, and you can put the progress and you can follow your progress on Google Earth. And this was the one project, and this is the overall, and you will know exactly when you look at your project when and where you are in the project. You will be reading easily. This is one project, and when we look at our other project, this is the Union Railway provided schedule, and here we are showing the one railway project. It is 260 kilometers, and it is in one page. And this project, it is planned in the TILOS And please see now on the left side, TILOS mentality, on the left side you have the time, and on the right side as a horizontal you have the distance, and here you can have your distance. And this is the Union Railway project in United Arab Emirates, and this is the distance drawings which is done in TILOS, and you are finding your all subpaths and all the structure which you can read, overbridge, underbridge, you can find in your schedule. And when you look at your activities, also they are defining you the duration of your tasks and with the different teams, such as clearing and grouping, and they are working at the same time at the different distance. So it is helping you to read the project. There are two teams here which you need to follow, and when you look at the certain time when they will be at the certain point. For example, at Railhead Depot, they will be there in the August 2011, and at the Railhead Depot they will be. So based on this, you can follow all schedule, and this was given by owner and contractors who would like to give offer, and they prepared their schedule in TILOS in detail with the combination of Primavera, so they submitted the project. And you don't have to show only linear activities, you can show non-linear works as well, such as here signaling, telecom installation. This is having lag here, please see here, and this is taking over 2 months, so you will be following your non-linear works as well with your constraints, with your milestones. This is the one project. So here the aim, having all the project, even if it's 260 kilometers, you are having this in one page, which is readable and with the calculated all the durational and the quantity based. And this was the one project. And another one, this is the project for this corridor. You can have your project, and please see here, this project, it is around 600 kilometers. This is the master schedule. This is the indicating just a sample of the project in India, and please see it is around 660 kilometer project. And what we have here, and what was the aim to manage here, when you're working in the, and this project was managed with Asta Power project and the TILOS exchange for the more detailing. And here we have our sections with many sections, and on the left side we can divide our views. We don't have to show only in one view. Please see that in our time distance view we are able to focus at a certain distance. So we were focusing here in this distance for around 600 kilometers. Now we will be looking only for the 85 kilometer, which is the first package of the freight corridor. And here, what was the aim of the company managed at the beginning of the project? And please see now, here the one thing, and this is the time based now. On the right side, we are having our quantities, and the quantity for cut, quantity for fill and subgrading, embedment, and for the ballast amounts. So we are all able to follow based on the time. Also we are able to follow based on the distance. Here we are seeing that, and here we seeing that this activity is not linear. And here the calculation, please see that embedment amount, it is here displayed, and when I move my task to another position, and it will be changing automatically because of the calculation on this task indicates that which you need to manage your work rate, productivity rate, it is 5,000 cubic meter, and this is reading from your profile, which is showing difficulties on site, which is showing your soil type, and giving you clear information for the formation works, and it is taking the amount from the fill amount. So you will be exactly following here what is the fill amounts at that distance. So it is reading the profile and it is taking, and based on this, it is calculating the duration. So here you will have realistic duration. For example, when you change the position of your team, embedding team, let's say, and now this task is taking 180 days. When you do this activity in another position, and it is taking 110 days. So based on this, you can make your analysis at early stage or at the executing stage, because your plans is changing constantly. So at the right side, you can follow that based on the embedment. The green ones, it is indicating the amounts for the filling and quantity for filling, and green ones, when you change the position of your task, also please see that here 2 months, based on the 2 months calculation. When you refresh your histograms, please see now when I change the position of my task, and when I refresh this, and the quantities also change. Please see that in this month also added the fill amount. So you will be directly following your monthly quantities on the histogram, so you will have your realistic project. Even your project 600 kilometers, even your project 10 kilometers, so you will be easily managing on the time based, and also in the distance based, you will be managing your project. This is the distance profile which you are managing. And one more project which I can show. We have, I think, 10 minutes, 15 minutes more to show. And in this project, we had different sections given to different contractors. And here the most important thing was the managing the peers, because there are over 160 peers here which you need to manage. And difficulties was in the onshore sectors, offshore sectors, different sectors, which I will show in a moment. Please see, and lot 1, lot 3, and 10 lots divided to this project. And the most important things are here, and here in the embedment sector, the owner of the work, just to calculate the just quantity at this point, I will be showing in a moment. And other profiles. On the top, always we are showing our distance drawings to synchronize with our construction site. So when we look at the details, please see now, these are the peers which needs to manage, and at the bottom also we are having the amounts, and here they didn't calculate the amount only at the part which they gave to contractor. They calculate the amount. I will show that part in a moment as well. At the bottom, we are having our activities, and when we just focus the lot 1, please see now, when we look at the sector, here the details, we can have multiple views just to show, to focus to some certain sectors. And here just I am showing the onshore sector. You see that it is not everything, just the lot 1 and lot 2, so I can easily manage. And these activities are taken from Primavera, and please see that all the activities now following the sequence. And now when I look at the activity filing for peer, and it is just following the sequence, and based on this piling, and the second activity excavation, third activity pile caps. And when you bring these activities from Primavera, also you are seeing that is there any logical mistake or any mistake based on the team's work. So you are seeing the direction of the works. You see that from the left side, which is starting at this point and going to right side, and you will know the sequence of the works on the time distance. Also, you could display this in the Gantt chart, but in the Gantt chart, you weren't able to display it. You weren't able to display in the sequence, which you can see. Please see now, you have activities here on the right side, like in Primavera, but you are not able to see the construction site. But when you are looking to time distance, the same activities but different representation. And we can speak about it more, and we can prepare for the progress view, multiple views, which will be helping you to follow at the execution stage of your project. And one thing more here, the mentioning seasonal data with recovery plan. And let's say that here the empty project, and at this blue parts indicates that it is the seasonal, and your work rates and productivity rates decrease based on your time period. And when you create an activity, let's say that without any effect of the situation for the seasonal data, so just you are having your project, let's say that you are starting the point and finishing at the 2,500 meters, and please see now your productivity rate, it is 500 cubic meter in a day. But if you plan based on your seasonal data, which your performance would decrease at this point, which is starting that with the starting at the same time at the same distance, and analyzing this, how it will affect. Now just to taking our seasonal data, please see that in the area which I am, and now my productivity rates, it is decreased, please see that it is 400 now cubic meter. And when the seasonal part pass, and now please see that I just go back to my productivity rate, and when I again meet with the seasonal area, and when I would like to finish at the 2,500 meter, let's say that we will be finishing at the same distance, 2,500, please see the difference when your activity finished. This activity finished in the January, here at the end of January, this activity finished at the end of June. So you can have, it doesn't have to be only seasonal, this can be maybe in summertime, you will not be able to work, or for the works, you will be working in the nights as well during the summertime. So based on your situation, you will be able to calculate when your activity completed. So these are the strength of the TILOS. Our aim is showing in time, distance, area, and analyzing it. You can have your soil classification, and you can have your all the productivity rates, and having your cost and income values to calculate your profit in the project. And of course, you can do this in the combination of your existing systems, so it is good helper for you. And some of the attendees, maybe we met face to face, and some of the attendees, for some of the attendees we just helped your situation, or we gave training to you, and you will know the capacity, and when you have any questions and how you can improve your schedule, and we are always helping you, because as FND we are provider of the TILOS in the Middle East, in the Asia, in Turkey, in Russia, in the East Europe, and with CMCS we are working in the Middle East around 15 countries. So we will be always supporting you. And here, just to show you the strength of the TILOS, one more thing, and you can have your activities like in Excel. You can import, export from the Excel, but you can also work like in Excel, such as you can sort your activities based on their name, based on their distance. Please see that just two simple things, it will be sorting you. Now we can also follow, for example, our station works. And when we look at the station works, all the activities inside in the summary tasks, so how you are get used to in Primavera or in Excel, how you are managing, you are able to combine all of them into TILOS. So what we have here, Gantt chart, we are having our Gantt chart, which are the same way how you are managing in your CPM solution, and also we are having time distance providing, like in Excel, we are providing this. When you would like to measure your progress, you are also able to follow your earned value items, such as these are the activities. Generally, you don't have many activities, but you are registering the activities in different locations multiple times. So these are the overall of the cleaning and proofing, and here 10 type of activities, but when we look at the progress for our teams, please see now, this is indicating us distance Gantt chart, and with the red highlighted area, we know that the team completed the work, and at this site, at this distance, they didn't complete the works, just they moved to 800 meters position and they completed the works there as well. So when you look at this, you will know where exactly not completed or where exactly completed. You are getting this, and in addition to this, you are having your all earned value items, you are having your cost performance index, you are having your schedule performance index, and as well as your progress based on the percentage, based on the square meter, or based on the quantity. So these are helping you to monitor from the early stage of the project until the close out to your project, you are able to manage. And after you close to your project, just you can keep your project type as a template in the TILOS. So when your next usage, when your next project preparation, it will reduce your time, because it allows you to have a library which is your knowledge base anymore. And these templates, such as this is some structure for earthworks, and you can use these templates in your next projects, just to having as a template in the TILOS, or you can exchange your libraries with the different TILOS projects. So in the TILOS, you can exchange your sub-projects, such as here there are three projects. One is the main, and it is also divided into 2 sub-projects. So there were 2 planners which was managing at the early stage of the project. So one of them preparing in plot 1 and one was preparing in plot 2, but in the main part they were merging the files and having the whole project, and at the weekly meetings just they were discussing that where they are at the planning and what is the risks for the project and what is the constraints, and with the briefings, so they managed the preparation of the work in a visual case. So for my part, I have more projects actually to explain, but for today, not to taking your much time, we can complete here, and we can recommend you to follow us on the LinkedIn as well. When you write into LinkedIn TILOS, you will find that some of our topics, you can attend our groups and you can follow us, and here you can ask your questions, you can follow the projects which is ongoing, and you can contact with us to ask and how is the samples of this industry projects. And also you can follow us on our blog to have more information in the TILOS, and if you are already user of TILOS, you can enhance your knowledge, and we can just help you for better project preparation and managing for linear projects. Thank you. And Mr. Bassam, if there are questions, Mr. Hubert can give answer, we can give answer.
Well, thank you, Tuna. And thank you, Hubert, for this great presentation.
Thank you for your audience.
And we will be actually making a special announcement for all the audience, where we're gonna offer a special package on TILOS Plus training. And if you have any further questions, please email those questions to us, and we will ensure that those questions will be forwarded and you get the right answer. And thank you all for attending today's presentation. And thank you again, Hubert and Tuna.
Thank you. Bye-bye.
Bye-bye.
Thank you.
Bye.